morning, dear participants. My name is Nurakhov. I'm from Kazakhstan. I'm presenting Institute of Mechanics and Engineering. Theme of my work: development of an intelligent oil management system based on digital twin and machine learning. You know, Kazakhstan is biggest in the world, most of the biggest in the world oil and gas producers. And the oil and gas industry area very important for our country. Introduction of work. Our project aimed to create a smarter way to manage oil fields using digital twin technology and machine learning, targeting enhanced operational efficiency. The primary objective of the study was to revolutionize oil field management by effectively integrating these advanced technologies. We set up a special stand based on oil displacement technology for our experiments, which is instrumental in efficiently extracting more oil from the ground. About the stand, a detailed experimental setup was designed using oil displacement techniques, equipped with sensors, actuators, flow meters, and solenoid valves. The experiments focused on displacing oil using water, polymer, and oil, from which valuable data was gathered. In our work, we use the technologies of digital twin, SCADA, and the LSTM machine learning model, Raspberry Pi for IoT controlling. Architecture of the system: oil reservoir simulation engineered to replicate the underground conditions of an oil reservoir. SCADA integration and SCADA interface to facilitate real-time data acquisition and serve as a window to our experimental setup. Cloud server and database integration to store data from sensors, historical data analysis to assess impact of diverse operational strategies over time. Machine learning model and neural network modeling deployed on the Raspberry Pi. We using Python language. Model structured with input layer of 120 neurons, 10 sensors in input, and 12 time slots. 2 hidden layers of 128 and 256 neurons. Output of 10 neurons. Optimization and intelligent control. Intelligent remote model for real-time operation using SCADA, PLC, and OPC UA. Architecture of our system. This is in low level instruments, sensors, actuators, pumps, flow meters, and valves. After we use 420 milliamperes signals, analog signals, and 010 volt signals, and discrete signals. Using Siemens programmable logic controllers and TIA portal program, and after OPC UA, and we use SCADA HMI for human-machine interface, and after Raspberry Pi with ML model and the database and the cloud technologies for cloud storage. Here, SCADA human-machine interface. Here you can see 2 reservoirs. This is like simulating develop oil underwater. For example, in first reservoir, you can see like oil with water and other components. And after we with our pumps give water for higher for take oil, and the oil because oil have less mass from water, and the oil in the top stay in the top of the reservoir, and with pumps we take it and put to second reservoir, and in that way we measuring how many oil we produce, and the temperature and the humidity of oil, and we can see all of that information in our SCADA, and we save all of information for use for our machine learning model. And here now we starting at the research, and we use only temperature sensors. After we're planning to use pressure and another sensors. Architecture of our system, we use LSTM model, time series, and here temperature of our system, and here you can see architecture of our neural network. 2 hidden layers and 10 sensors in input. Results. Our SCADA system recorded live metrics like reservoir pressure, temperature, and oil migration. This data was fed into our digital twin system, generating a lively model of the testing environment. ML models were trained using past records and further employed to refine testing variables. Our experiments yielded several notable results. Boosted oil extraction, surpassing traditional techniques. A greater volume of oil was mobilized from the reserve. So real-time observation and the predictive maintenance features of the digital twin setup. Potential equipment failures were preemptively pinpointed. This is very important things too, because with our ML model, we're planning to add vibration sensors to predict failure of equipment. Our intelligent framework routinely amplified oil extraction. This is we use faster equipment for experimental digital oil field test bench. It's looking like that. Siemens controllers. All of data sending to cloud. Visualization in SCADA. And we have predicted temperature. And we compare with previous data, and we have 95% of our neural network with loss visualization. Yeah. I finished. Thank you.